13.2, verifying trig identities. So basically this is the harder version of what we did last time. So we're going to go deeper, more advanced. So when you verify a trig identity, the general thing you want to keep in mind is that you're trying to make this side look like this side or vice versa. So the number one rule is you cannot work on both sides. You're trying to verify that these things are correct. So there's like an imaginary wall here. You're going to try to either make this side look like that side or, the other way around. So keep in mind, you cannot do the same to both sides. And all we gotta do is just simplify one side as much as we can. Sometimes just simplify both sides, but you just try to make them match. One thing I would say, you want to work on more complicated side. This is complicated. Like here, I can't do anything over here. 1 plus cosine is nothing. There's nothing I know about 1 plus cosine. This side I can work with. Now, again, this will be more advanced. So first thing, notice how everything's a cosine. I probably want to get rid of that sine squared. So you gotta think, what does sine squared equal? Now I could change it to 1 over cosecant squared, but that's not gonna help me because it's all cosines. If you remember, sine squared is one of the big ones. Sine squared plus cosine squared equals 1. So sine squared by itself is gonna be 1 minus cosine squared. Again, one of these we're going to use so much you have to know it. So this top thing here is going to be 1 minus cosine squared. This should just all be thetas. So I have this, 1 minus cosine squared over 1 minus cosine. I'm trying to get 1 plus cosine. So now don't fall into the trap. Remember, the ones do not cancel. The cosines do not cancel. They're stuck. They're in parentheses, right? There's multiple things there. Unless they're being multiplied, you can't cancel them out. So what do I do next? We factor. This could factor. Again, we're doing more advanced now. Look at that. 1 squared minus cosine squared. It's the difference of 2 squares. It's this thing. Alright, we're honors. Factor like that. So 1 minus cosine squared, you can factor to 1 minus cosine, 1 plus cosine. So it's 1 minus cosine squared, cosine theta, sorry, and 1 plus cosine theta. All over 1 minus cosine theta. These cancel, because now we're just multiplying, so now you can't cancel them, because these are multiplied. End up with 1 plus cosine, which is what the other side matches. Right, now we have 1 plus cosine on both sides. That's verifying a trig identity. You're trying to make both sides match by doing some mathematics. I know, tough, but the way you get better is by doing more of them. So now we have this one. Let's try another one. So again, I have to work on one side or the other. Sometimes I work on both sides. I think this one might be one of those. So on this side I have cotan squared times cosine squared. Let's work on both sides. I think a lot of times that's easier. So let's work on the right side real quick. So over here, remember the general rule is if you're not sure what to do, just change everything to sine and cosine. So I'm going to leave cosine alone. Let me change cotan. Again, you got to know what these definitions are. Cotan is cosine over sine. Because tan is sine over cosine, cotan is cosine over sine. Since it's squared, it's going to be cosine squared over sine squared times cosine squared. So if I multiply that, I'm going to get cosine to the 4th times sine squared. And that's about as far as I could go. I'm not even sure if I should multiply that, but I'm pretty much stuck there. On this side, let's rewrite them. Right, cotan is cosine squared over sine squared. Cosine I can't do anything, so let's put cosine squared over 1. So I have that. Now here's a trick we're going to do a lot. Notice how this is cosine over sine squared and this is cosine over 1. We need the common denominator. So let's multiply this side by sine squared over sine squared. And then I'm going to get common denominator. I'm going to get cosine squared minus cosine squared sine squared all over sine squared. I have thetas. You're like, that looks nothing like that one. We're not done yet. I gotta keep on going. Is there anything else about this top here? Again, we're doing more advanced. They both have a cosine. So if we could factor it out, I'm gonna get 1 minus sine squared left over on the inside. Again, they both have a cosine. Factor it out, you're left with 1 minus sine squared. And then now you have 1 minus sine squared. We kind of just talked about this, right? You have to know the definition. You cannot do this if you don't know the definitions. 1 minus sine squared is cosine squared. Cosine squared times cosine squared. Cosine to the 4th. Which matches what we had right here. So left side matches right side. Again, right, it's all about just working with what we got. Cotan squared, cosine squared. I'm not sure what that is. I'm going to rewrite cotan squared. So cosine squared per sine squared. And multiply it out. I got that. Over here, I just had to rewrite it. Common denominator. And then factor it out and solve. Next one's more of a matching one. So a little Scantron version of this. So again, we got to simplify. Now there's lots of ways you can do it. You can try to simplify the bottom. You distribute. I'm actually always more of a fan of distribute first and see what happens. Let's see what happens. So I'm going to get tan squared theta cotan squared theta minus tan squared theta cosine squared theta. Alright, so I get all of this. Now I got to simplify. Now tan times cotan, hopefully we realize that they're reciprocals of each other, so you cancel each other out. You just get 1. Over here, tan squared cosine squared, I'm not sure what happens to those. I'm going to rewrite a tan. Remember, you always want to keep sine and cosine. Rewrite tan. Tan is sine squared theta over cosine squared theta. And cosine squared is just cosine squared. Simplify. These cancel. And I get 1 minus sine squared. You're like, you're done? No, you're not. That equals something. That is cosine squared. H. Alright, so that's how you simplify, right? Just simplify one side. I like to distribute if you have a chance, and then just see kind of where everything lays. Next one. Classic problem right here. So we have this problem right here. Again, we're trying to make the two sides match. The whole point is to verify that they match. So you're going to try to make the left side look at the right side. Let's start with this side a little bit first. I can do a little bit with this. Anytime, I don't like fractions, right? Nobody likes fractions. Let's make this not a fraction. Let's move it to the top. If you move to the top, it becomes cotan. It's a reciprocal of what it is. So I have secant times cotan. So now you can rewrite it. So this is just secant cotan. Secant is 1 over cosine squared. Cotan is cosine over sine. If you simplify this, that cosine cancels out with that cosine. And I get 1 over cosine sine. It looks like about as far as I could go. Now let's look at the left side. Again, if we're not sure, just change everything to sine and cosine. Cotan is cosine over sine. Tan is sine over cosine. Now again, keep in mind, they do not cancel. It's a plus sign, not the multiplication sign. You cannot cancel anything out. What we could do though, so we're going to do a lot more today, common denominator, right? This is sine, that's cosine. It's like adding 1/3 plus 1/2. You need to do a common denominator. So you find out what they both have in common. In this case, 2 and 2 and 3 and 3. In this case, this has a sine. It's missing a cosine. This side has a cosine. It's missing the sine. If you simplify, you're going to get cosine squared plus sine squared all over cosine sine. Last thing, cosine squared plus sine squared, right? It's the biggest rule in trig. 1. Cosine squared plus sine squared is 1. So you get 1 over cosine theta sine theta. And they match. Next one. Look at this one. You're going to have cosine squared equals 1 plus sine, 1 minus sine. Remember the thing I like to do, if you see something like this, distribute. So let's do this. 1 minus sine x, sine theta, plus sine theta, minus sine squared theta. The middle two cancel, and I get 1 minus sine squared theta. You know what 1 minus sine squared theta equals? Cosine squared. Right? The most important rule of calculus is all of trig is all that sine squared plus cosine squared equals 1. And there you go, they match. Right? Again, can't forget this. Right, and that's where I got this from. If I subtract sine from both sides, I get cosine squared equals 1 minus sine squared. If you subtract cosine from both sides, you're going to get sine squared equals 1 minus cosine squared. So very, very important. Next one. Oh, this one sucks. So right here, if you notice, I can't work on the left side. Sine, I can't do anything, but the right side I can, and that's a mess. So I can't flip it up because of the plus sign. What I could do is work with the thing back down here. Let's see what tan theta plus cotan theta is. Tan is sine over cosine. Cotan is cosine over sine. We've actually done this before. I cannot cross cancel. It doesn't work that way. You need a common denominator. And the common denominator right here is going to be the side's missing sine, so multiply by sine over sine. The side's missing cosine, so cosine, cosine. And I get sine squared plus cosine squared over cosine sine. This is 1, so I just get 1 over cosine sine. So this turns into be secant 1 over cosine 1 over sine. Right, so now it's just an algebra problem. Remember, this is secant divided by these things, so I'm going to rewrite it. So secant divided by 1 over cosine sine. When you divide, you multiply by the reciprocal, so this is going to be secant times the reciprocal of that. So just flip it up. Cosine times sine. And what happens is here is secant and cosine are reciprocal functions, so they cancel, and you just get sine, which is what you wanted. Choice with the theta. I get lazy and forget. That's the idea. So let's do some more. Now, all the ones we do here, you can only work on one side because the other side was too basic. Now you're going to do ones where we work on both sides again. So same idea applies if you have a chance to distribute, or substitute. Only work on one side at a time. Now we're working on both sides. And actually, this first one we did already. That's the one right there. So that's a waste of space. Let's go over here. So again, I got to make these two sides match. So I'm actually going to work on this side. Distribute. Again, I always like if you have a chance to go ahead and do it. So secant squared minus, the difference two squares, plus secant minus secant plus minus 1. These will cancel, and I just get secant squared minus 1. Now again, if you have the formulas memorized, you're like, wait, secant squared is the same as saying 1 plus tan squared minus 1. So these cancel, and you just get tan squared, which is what I wanted. Another way to do that, if you're not sure, and you have secant and you're trying to make it equal tan, you could rewrite this as 1 over cosine squared. Try to do a common denominator. So multiply this by cosine squared to cosine squared. And you get 1 minus cosine squared over cosine squared. 1 minus cosine squared is sine squared. Sine over cosine is tan. So again, two ways to do it. The basic way if you know your formulas, and the slightly more harder way if you don't know your formulas. Next one. So this is one where I definitely have to work on both sides. So I don't care what side you work on first. Just try to simplify one side as much as you can. So this side's a little easier. Let's work here. So remember, first rule, you don't just distribute that way. It doesn't work that way. It's not how math works. You have to multiply by itself. So sine theta plus cosine theta times sine theta cosine theta. Then we distribute. I'm going to get sine squared plus sine cosine plus sine cosine plus cosine squared. These two match, so you're going to get sine squared plus 2 sine cosine plus cosine squared. Now if you know something else, sine squared plus cosine squared, right, that equals 1. So these two put together is just 1. So I'm going to get 2 sine theta cosine theta plus 1. That's as far as I go on the left side. Just simplify it, multiply it out, and you get 2 sine cosine plus 1. As far as you could go. The next side, we're going to use the trick I talked about. Remember, if you have secant, cosecant on the bottom, we don't like fractions. You can move it to the top. And when we move it to the top, since we multiply, you can do that. You multiply, but you reciprocate it. You flip it. So secant on the bottom is a cosine on top, and a cosecant on the bottom is a sine on top. So this side is just going to be 2 plus secant cosecant times cosine sine. So if we do that, Well, if we get distribute, so we're going to multiply this by both of these. I'm going to get 2 cosine theta sine theta plus secant cosecant cosine sine. Now again, if we know anything about graphs function the reciprocal, they cancel each other out. It's like cosecant and sine cancel each other out because we multiplied. Secant and cosine cancel each other out, so because we multiplied. So you just get 1. So you get 2 cosine theta sine theta plus 1. So there you go. They equal each other. That equals that side. And the whole point you want to do is make these two sides match. So simplify the left side, then simplify the right side, and hopefully they match. Last one. Classic IB problem. Classic, I should say, trig problem. So they want you to make these two things match. Now, a lot of people try to do this. Like, oh, let's cross multiply. You can't do this. Remember, we're trying to verify. You can't assume they're equal to each other. So you don't do that. Can't. Each side's different. So this is a trick to this one. It's a trick and you get it from doing this a lot of times. The trick is this. If I want this side and this side to match, well, I'm trying to get 1 minus sign, 1 plus sign. But we're gonna multiply, let's say this side, by its conjugate. You might say, why? Well, we do it on purpose. When we multiply by the conjugate, that means we're going to get a squared minus b squared, which means we could factor. That's what the conjugate loves to do, right? So on this side, let's multiply by the conjugate. 1 plus sign. Remember, conjugate is just when you switch the middle sign. So conjugate is if you have this, multiply it by this. And that creates the difference of 2 squares. So 1 plus sine x. So on top here, I'm going to have 1 plus sine x, cosine theta, all over. Now, if we multiply 1 plus sine x times 1 minus sine x, we're going to get 1 minus sine squared x. I know what you're thinking. Hey, those don't match still. Relax. So how am I going to make these match? Well, you might try to factor this, but then you're just going backwards. If you factor this, you're going to cancel out. You're just going back to where you started. Instead, we're going to do this. Do you guys remember? I'm trying to get a cosine down here. Remember what 1 minus sine squared equals? Cosine squared. So I'm going to have 1 plus sine x on top, which is what I want anyway. I'm going to have cosine right next to it. And on the bottom, I have cosine squared. And what happens here is these two things cancel. And look what you're left with. 1 plus sine x over cosine x. And that matches, and that is it.